Hi, thank you. Next slide, guys. Hello, I'm Christopher Jackson, co-founder at Advanced Infrastructure. We build detailed digital twins of the energy system. We're joined in this project by Regen, who are well known for producing some of the DFES studies for distribution network operators forecasting their future strategic demand. And we're also supported by Sheffield Solar, who's well known in the industry for supplying PV live and PV forecast data to National Grid and other stakeholders. Next slide, please. So at Advanced Infrastructure, we've built what we believe is the most high-resolution digital twin of the energy system available to the public. And you can see that in the slide to the right. Just explaining what actually that means and why it's relevant, let's go through the different data and the different data layers. In the red dots, you can see the grid service points or proxies for thermal generation. In the UK, there are around 360 thermal generating plants. When we first set out, we asked essentially the industry and National Grid, where are these plants located? And surprisingly, the answer was, we don't know. We know where they're connected, but we don't know where they actually are. So that was an example of a data set that we had to mine ourselves, and we used a brute force approach to cite them correctly on the UK map. Next, we tried to identify the 2,000 or so wind farms in the UK and had similar problems, so then had to identify where they were and cite them correctly through another data set. Finally, we wanted to add in the 1 million or so PV stations there are in the UK. Unfortunately, Sheffield Solar were able to provide us with a geolocated data set. The next challenge was to try and get live generation data. Elexon was very helpful with that. Through the API, we could attach that to most of the thermal power stations, some of the wind farms, and a handful of the PV stations. For the rest, we actually had to create synthetic models in order to produce an integrated and aggregated data set of all PV, of all generation in the UK. Finally, having built that data set and then collated 10 years of historical records, we overlaid ONS LSOA levels, which are population zones, population polygons of 10,000 people. And then we, as a proxy for a carbon signal, we attributed the PV outturn to different population levels. That gives you the colored layer in the background, which is one of the most highest resolution carbon signals available on the UK market. Now, this was a lot of work, and any company wanting to innovate in the digital space in the energy sector probably needs to go through this 6-month learning experience themselves. And it's something which we thought, shouldn't that be turned into a commercial product in itself? A cloud-first platform using a common analysis framework such that everyone can use that as a starting point and build their models on top of it. And essentially, that was the reason that we have decided to develop a common analysis framework and apply that now to the problem of local area energy planning. Next slide, please. So what's the problem here that we're trying to solve? The UK needs to deploy low carbon technologies at a rate of 40 billion per year. At the moment, we're doing only 20 billion. And the reason the bottleneck is not financing, it's actually planning and the ability to site these low carbon technologies in integrated systems at speed and at scale. So next slide, please. So in a common analysis framework, there are generally 3 elements to this, and each of the partners in the projects have relevant experience. So on the left-hand side, Advanced Infrastructure is developing a digital twin and a detailed network map. And the novel approach that we're taking is we're crossing the traditional boundaries between transmission, distribution, and behind the meter to build a very detailed plan. Secondly, Sheffield Solar is helping us with detailed generation outturns, and Regen is specializing in high resolution demand maps as well. Final slide, please. So what we'll be doing throughout the rest of this project is improving the digital twin and developing the common analysis framework such that local area energy planning can be done at half the cost and twice the speed. Thanks very much.